This video is made possible through the support of Andrew Cole. If you're interested in supporting one of these videos, check the links below in the description, get on a Patreon, and see how you can help out. Thanks! Hi there guys, welcome to today's Captain's Blog. We're back on the bench where we're going to do a wrap-up on the 3D printer thing because my parts came in. And we're going to get to explore the Thermistor at a level that you've probably never seen before because I have rocked some mojo and I've got some really cool lighting. Like I dug out some antiques. I have the world's crappiest macro photography lens, the cheapest lens that money can buy. And we're going to dig deep into exploring just what you can see, like what you can look at with a hot end and with a Thermistor because they're pretty cool. Like this is like really neat, tiny stuff and I'm digging it. So we're just gonna explore the stuff and look at it and we're gonna put the whole thing back together. And yeah, that's the plan for today. So let's get to work. What we have, if you look here, this is the tore down bits of our hot end, but we don't care about this right now. So we're gonna get that other shot. Yes, I know. Red shift, blue shift. It was for a live show, and this is why you should watch the live shows. So don't judge me, because I'm fabulous. Fabulous. We did it for a live show fundraiser, and you'll get to learn all about that in an upcoming video, or just tune into the live streams. I'm on, pretty much every night at 10. But this is our heating element here, and this crufty nastiness is our Thermistor. And as you can see, our Thermistor is hosed. So I don't know if this died in use, or if this died from me killing it, or what happened. Either is very possible. They're crazy delicate because, as you can see, they're crazy tiny. There's my finger for scale. And it's just a little glass ball with some magic electronic bits inside and a couple really thin wires and what looks like Teflon insulation. But we got to replace that, and that's our first order of business. And after we replace this, we're going to come back and get a good look at this and really explore it. But to start out with, I got to replace it. So I have a replacement Thermistor, and it comes on a pair of long wires. Really long wires. Wires that'll go almost all the way back to the other end of my thing, but not quite. So we're gonna splice this in. We're gonna do like they did here with, like here they did obviously solder and heat shrink. I might solder it. My soldering skills are kind of legendary. I'll probably like do a crimp connection. But first we gotta cut the old one out. And that's a job in its own right. Because I gotta take all these zip ties off all the way up the thing. So let's grab our little nippers and let's do a little surgery here. Here, we're just gonna, right in there, just like that. And you wanna be careful not to cut anything else. You're not gonna hurt the tubing, not cutting in this direction. There's not really any danger of nicking that. But the sleeving is made up of a million tiny parts, and that's easy to screw up. By the way, if you don't own a pair of these nippers, I recommend them highly. Little tiny flush cut nippers. I use the hell out of these. They're really quite lovely. So we're gonna take all this apart. And that's just going to get our hot end right out of there, like the metallic part and the tube part. We don't need that because it's an electrical job. Take all our old zip ties off. And we're going to take, this is going to suck because this is my plug on the end. By the way, comment if you know what the name for this plug is. Like, I'm sure it has a name. I honestly don't know the name of this one, and I'm curious. But we gotta... Oh, there's no easy way to do this because everything's terminated in this plug. and I'd want to slide everything off this end, and I'm going to have a limiting factor of how far. Oh, wow, okay. All right, we're not as limited as I thought. We can run this way the hell up and just zip tie this, and that'll hold it. And I can make my termination somewhere midline on that. Oh, that's great. Okay, we'll just run that way up there. Thus, and now I had tons of room to operate here. Okay, and I'm going to replace both the heating element and the thermistor because this is pretty crusty. That's kind of gross. So we're going to replace both of these. And yeah, I'm going to cut all 4 wires, replace all 4 wires, because I've got Teflon wire here, and this is some heavy insulated. It's kind of waxy. I don't know what this is. Kevlar? Maybe? I don't really know. What is this? What kind of wire is that? What kind of insulation? I'm going to say Kevlar. Though cheap Chinese could be asbestos. It's probably not asbestos. But we're going to cut off both of those at different points because I'm well away from the hot end, and I'm going to come like halfway down on that. We'll cut that one there, and then a couple inches further up, I'm going to cut this one so that my splices don't line up. Now we're going to set these aside for now because we're going to get a much closer look at these. I really want to explore this and see what we can learn about that and the particular way that it died. So take a look at the end of this. This is the red wire for the heater unit. Inside it's white. And we're going to get a closer look at that in a minute, but I think that's Teflon on the inside. I think that's a heavy-duty Teflon insulator. So we're going to strip this back with my big old strippers. These aren't my sexy Nipex ones, but those are out in my tool bag. And I can't be arsed to go out to the car and get them. Hiding down here in the basement. This is where I hibernate for the winter, and that's just how it works. Okay, so we've got the red wires done. Now we're going to do the white wires. The white wires are for the thermistor. So here's my white wires, which look suspiciously similar inside. Yeah, I think these are Teflon, and I think the inside of that is Teflon. And they use Teflon because it's a high heat application. Like, it isn't high heat way out here, but it's high heat up where it's, you know, because it's working in the hot end. I'm going to strip these a little long because I can always trim them off easily, but I don't want to have to do another round with the strippers. Now I got Sapobi. These were sent in by a viewer, live stream viewer, thank you. And I happen to have some very tiny ones. And then I got some not quite as tiny ones. And these are what's called solder and seal connectors. Now there's no instructions with them at all, but what I think, I could be wrong, and if I'm wrong we'll cut it out and start over. What I think, and I'm pretty sure, is that in looking at this connector, it looks like a piece of heat shrink tubing with a couple little bands, probably of adhesive, and then that center band I think is a low temp solder, and it'll just melt. Like if I put the wires in there and hit it with a heat gun, I don't have to crimp this at all because that's really thin. Really, really thin. So I don't think that's a crimp connect. I think that that's you put this in, hit it with a heat gun, and that melts and it becomes solder. I'm pretty sure. We'll know pretty soon. Let's find out. All right, so we'll need a couple of these. I got plenty of extra because they come in a 5-pack. And this You just need one. Now these come in two flavors for like this particular series. There's a 12 volt and a 24 volt version. And people smarter than me unanimously agreed, well, that ain't gonna work either, is it? Okay, so let's just untie the whole thing. That I absolutely positively have the 12 volt printer. So I ordered a set of 12s, and I have a quiet faith that this will work. And if it doesn't work, it's going to fail really fast and probably involving some spectacular amounts of smoke. Come on. Remember the video on how to rosette a cable? Also works for cable-y parts when you have a bunch of them. Makes it a pain in the butt when you got to take just one out. You got to untie the whole thing, as we just learned. But it's a simple, easy, clean, and relatively neat way to store parts, especially since I don't have to reach for these terribly often. And I have decided that if this becomes a thing where I have to swap out hot end things on a regular basis, that where the hell did I put? Oh, that I'm going to put crimp-on quick disconnect fittings on the wires. Okay, we're good there. So we have our new hot end, and I'm going to use the existing thing to figure out how long to make it, and probably leave a little extra, because it doesn't hurt anything to have a little extra wire in there. I'm going to add, let's say, 3 inches just for safety. Yeah, that'll be good. And then cut these. I'll save these for something. That just goes in my little scrap wire drawer. And then we'll strip this one just like the other. And then clean up our flyers on here. So you can see on there, there's a little flyer. You want to clean that off, especially if you're going to be soldering. That's not made of the Teflon though, so it would probably melt. You can see our strands are all separated, so we're going to give those a twist. Okay. Now I believe that A, this is a resistive heating element, so it knows no polarity. I'll spin those together. And that I can just slip this in this side, stop there, and slip this in this side, like that, and let them overlap in the middle. Now I believe if I hit that with a heat gun, that center thing's going to melt, and then we'll see the solder melt inside there. Well, the heat shrink works right away. Oh, look at that. How cool is that? It melts. You can see the solder inside melting. That's so cool. That's really neat. All right. And that's our first finished joint. That's super cool. I like it. That's so neat. I've never done one of these before. It's kind of gummy. It's really soft. Yeah. All right. I learned a new thing. I'm just going to set that aside to cool, and we'll grab the next one. The only thing I don't like about these connectors compared to like a regular crimp butt connector is that with a regular crimp connector, you can do each side individually. You can like get the wire in, give it a little crimp. Alright, now we can see we've got those overlapped. Now this is going to be fun to hold because it's going to get hot real fast. But let's do what we can. Because I think I can just seal one side. And then totally set that down. Change hands, make sure I'm in far enough. Grab the heat gun. And then make the connection without blocking the camera and get the solder to melt. Get the thing in focus. There's a lot going on here. Now we can see the wires actually overlap a little bit, but it's inside the thing, so that's not going to hurt anything. I don't think so anyway. I want to straighten that out so at least it cools in a straight line. Looks alright to me. What do you think? You gonna melt that? Melt that little bit there. All the cool kids are doing it. Makes you look older. Oh wow, that melted and spooged right on out. I think I might have over melted it, but it went from like nothing to oh, okay. Alright, so that connector is now soldered and sealed. And all 4 of our electrical connections are good. So I'm going to give this all a minute to cool. And then we'll slide the sleeve down. So now we have to very, very carefully cut this. Or I'm actually going to cut it out in the middle of the lock here. Because I don't want to risk nicking any of those wires, because that would really suck. So we're just going to have to work our way through this, which is kind of hard to cut. But if I cut this, I won't nick the wires. Also helps if you cut it all the way through. Okay. Now we'll just take that off. See, that way I don't risk damaging the wires, and that would be bad. And then we just slide the big snake down, and all of our joints and everything just vanish inside. And then I'm gonna lace this back up with zip ties and add some little ones. I'm gonna grab some little zip ties. Alright, so we're gonna use some small zip ties to lace this up. They're a little bit, they're just a hair smaller than the originals. And I'm gonna smooth this down as I go. The outer black sleeve is really just to keep the wires bundled together, and out towards the end maybe a light bit of abrasion resistance, because this has to rub against stuff a lot. But the main purpose is it just keeps the wires from getting tangled into things. I'll put one of these about every 5 or 6 inches up the thing. And I want to say hi to Clifton, who just tuned in on the live stream. You guys should know, if you check the links in the description, you can actually tune in and watch me fumble my way through these video shoots. I do live streams every night at 10, usually, almost every night. And you're welcome to tune in, hang out. And most of the time I'm in the shop, not usually when I'm actually shooting like a production video like this, but most of the time I'm in the shop. There's actually a Discord channel, links in the description, where you can come and hang out. So here's a little trick, handy to know. When cutting these, don't just come in raw. Very lightly pinch, just barely touching, then slide all the way up, and you'll cut them off flush. This is especially important when working in boxes and stuff like that, to cut these off flush, which is why you want to use a pair of these little flush cutters. They're super cheap. Okay, you can get these super cheap. Get a decent pair though. Like a pair of these should cost you about 10 bucks. You can get them for like $4. Menard sells them. They're like the Workforce brand or something like that. They're garbage. They're absolute crap. I bought a pair, very disappointed. But these, nice long handles, they fit the hand, and like you're not going to be cutting 500 MCM with them, but for zip ties and small wire work, they're lovely. Like if you're into electronics, get a pair of these. I've got like 3 pair. This is one of the most reached for tools in my shop. Absolutely. Like that's just a fundamental thing. Knipex makes a really good pair, but they're pricey. I don't own a pair of Knipex ones. I don't think so. These aren't Knipex, are they? These are Kleins. Oh, these are good. Yeah, that explains why I like them. They're Kleins. Okay, the Klein makes the good ones. Now you know. So we've got this sorted out. All of our stuff is together. And now onto assembly and the metally bits. So for those of you that tuned into the previous episode of this adventure, I've had that percolating since then. So it's been in there for the better part of a week. And what I did is I filled that with acetone, and I used the butt plug. Don't judge me. It's one of my own. It's not one of my personal butt plugs. I designed it. So that is my butt plug. And you can get one. If you're interested, let me know. I sell them. But I've been using the butt plug to hold in the acetone fumes, and it all evaporated. So clearly my giant butt plug isn't tight enough to hold in my acetone fumes. And now we got to clean this off. So, but look at the shit in there. All that. I had people commenting saying, acetone won't melt PVA, acetone won't melt PVA. Did you watch the video where the acetone melted the PVA and I used it to clean it off? Because that was the same video that you commented on where you said the acetone won't melt the PVA. Also, see all that shit on the bottom? All that yellowy shit in the bottom? You know what that is? That's PVA. And some oxidation and some schmoo. And it was all melted by the acetone. There's still some schmoo on here, but we're going to clean that off, and we're going to get a really good look inside this, because I gotta clean that crack. I got crack issues because my butt plug didn't get a good enough seal with my acetone fumes. So let's grab some acetone right here, and I'm going to put on some safety glasses, because I have upgraded my safety glasses mojo, which is pretty awesome. And a big thank you goes out to Avitech for that. I'm talking about tools that you should own. Uvex Tomcat safety glasses. Oh my God! Now my regular ones are sitting upstairs. These are the outdoor sunglasses. They're divine. They're the greatest safety glasses that have ever bespectacled my ugly mug, and I like them a lot. So, and they're going to be fine for like acetone. So let's squirt a little bit of this in here. I'm just going to put a little bit in the bottom here. Swirl that around. Let it dissolve everything that's in there. Oh yeah, that's way better. Now, my shop has a concrete floor. And I have a tiny, well, I have like 5 cc's of acetone in here. We're going to add a little bit more. All right, clean that off really, really good. Just mix it around. And I'm going to grab those. Okay, so tasty. I'm just going to agitate that. And this is just a quick rinse off. We'll come back to cleaning this better in a second. But you can see all that. Okay, and it dissolved, it instantly dissolved all the stuff in the bottom of there. And I'm just going to dump this right on the floor, because that'll just flash off and evaporate. And the little bit of yellow schmoo, this stuff, wipe that off on my pant leg. Okay, so now we got to clean this for reals and get all the last of the schmoo off of it, because we're going to assemble this. So I'm going to do this working in an acetone bath. Now we're adding a lot of acetone. Yeah, that'll do. We'll set that aside. Agitate this some more. I want an ultrasonic parts cleaner really bad. I got one on my Amazon wish list. I might make that happen at some point. It's a couple $100. They're not too bad. They got like a little, I think there's a 6-liter one on there. That's really nice, and that'd let me do like big parts. Like you could do carburetors in that. Okay, now let's see where, well, we're just going to let this soak for a minute. Don't do that, that's dumb. And I'm going to grab a razor blade over, I got an X-Acto knife, don't I? Alright, found an X-Acto knife. Also, I found these are the Master Force nippers. These came from Menards. Absolute garbage. I had really high hopes for these because they're flush cutting and they've got like really nice grips, but they're actually, because they're so short, they're kind of uncomfortable in the hand, and they're dull as fuck. And just these are the exact opposite of these. The Kleins are the good ones. And I've got my old friend, the X-Acto knife. This is a larger sized handle than this blade wants, and this is the one that I stabbed myself with in the previous video. Let's see if I can do it again. So we'll shake the acetone off there. Now we definitely got some more schmoo off of this, which is cool. And let's get you a better shot. So what I want to do is clean out in that gap. I want to get this all cleaned out and make sure there's nothing in there, because this is a clamping surface. This, oh wow, Jesus. Yeah, see, that's what I want out. This gap here squeezes together and clamps the heating element. So the heating element goes in here, and there's a screw that goes in one of these, and the thermistor goes in the other here. Okay? But this, you can see there's two. These are where the bolts go through, and they attach in here. These will be threaded in here, and then this is slit. And this slit compresses, and that reduces the diameter here, and that's how it clamps down. So you want to make sure you don't have any schmoo gunged up in here. So we gotta get all that cleaned out. I can just hold on to this. Yeah, there's a lot of shit in there. You can see some shmoo down in there, but we'll get to that. Okay, and we'll drop this in, give it a spin. It's refreshing on the fingers as the acetone evaporates. Okay, so that appears to be about as cleaned out as it's going to get. And now, to clean the bore of it, the acetone's taking off my nail polish. Pro tip, fingernail polish remover is actually made of acetone. We're going to clean this out really good. Oh yeah, that's good. Alright, now we're going to make sure this is clean up here. Now I think this threads into there. I'm pretty sure of it. Let's do a quick final cleaning because this is its last chance to really get anything cleaned off of it. And we'll grab some more Q-tips. Okay. I think it's funny there's fingernail polish on the thing now. But acetone will take that right off. See, and this is all the last tiny vestiges of the great schmoopocalypse of 2019 as we clean this all out, and it's now totally ready to go back into production. I want to get every nook and cranny that I can. So I got these little holes that I'm worried about. But I know how we can take a look in those. Let's break out the secret weapon and get a real look in these holes and see what we're actually dealing with and make sure they're clean. Okay? Watch this. You ready to see something amazing? How you like that? That's our orifice. You can actually see down through it a bit. You can see light out the other side. Now what I want to check out is that groove. Okay, we're going to take a look right on down through it. And we can see all the way down through that groove. There's our hole. Now that's the money shot. That's what I wanted to get a look into. Can I get some light in there? I don't know. But it looks pretty clean. I think it'll do. At least as good as we can see down in there. Now what you're actually looking at, let me grab an X-Acto blade so I can point it out. This hole here, the bigger hole you can see is threaded on the inside just barely. It doesn't really focus very well. But you can see this hole is threaded. This is where the screw goes. By the way, the thing you're looking at, the pointer, is the tip of an X-Acto blade. That's the X-Acto I was just using. This is where the thermistor goes, and it's important to make sure that this is clean. So we're going to squirt a little acetone in there, and I'll just pick that out because I can't visualize it really well. Like, I can see that the hole's reasonably clean, so I'm not too worried about it. Now let's flip this over because I want to see... I gotta find them. Oh, they're on this face. Hang on. Alright, so these are, you can see the slot there that we have to clamp on. So we're going to look right down into that hole, and I can see light through it. I can see it's reasonably clean. Let's go look at the other one. Yep, it'll be okay. There's a little bit of gunge in there, but nothing that's going to matter. Like, we're looking microscopic at this point. So there's the inner flange. Here's the upper face, and then we'll zoom into the inner flange. That's the pocket, and then we'll zoom in deeper, and you can see down through the hole itself. You can see the walls, which is kind of cool. And that's my finger behind it. So all in all, I think we're good. I want to look over here. This is where this is our output hole. Now what's that? That looks like there may be some manner of clog in there. Or maybe that's just a really tiny orifice in there. I don't know, but I'm going to squirt it with some shmoo. I'm going to squirt it with acetone. And run a pick through there. If that's a metal orifice, I won't damage it with a soft plastic pick. And if that's just shmoo in there, I'll dislodge it. But that's, we're looking down through, that's up from the bottom, like these threads back here, that's where the nozzle screws in. So we're looking up inside the hot block, the hot end block, through where the nozzle would screw in. How's that for a cool shot? Alright, let's clean this out and then we'll assemble it. Okay, so we have to clean out. Where we were looking was up this hole. And I don't know if that's intentional or not, the little goop in there. So what we're going to do is force some acetone through the hole. And I happen to have some super tiny little cleaning foam swabs that absolutely dissolve in acetone. But we're going to try poking one of those up there. And we'll find out if that goop is intentional or not. Let's well, a goop is clearly not intentional because we're running a thing up there and the hole opened right up. Yeah, that's way better. Yep. Alright, so we got that. Cool, so I'm declaring this block clean. And we'll dry it off, let the acetone flash off, and we'll assemble it. I'm just doing some thread cleaning at this point. So cotton swabs, impervious to acetone. Foam swabs, totally destroyed by acetone. Because the foam dissolves. Oh wow, yeah, I'm glad I cleaned that out. And I'm just running the threads on these. I'm running these in like chasing it with a tap. Yeah, that's clean. Cool. All right, let's build a hot end. So there really isn't a whole lot to this. We need a couple basic tools. We got to put one screw, one Phillips screw, two Allen head screws, and an Allen head grub screw go together to make up this assembly. And it's pretty simple. So let's build it. All right, so we've got our little bolts. This is easy. You can do this, but you're going to need a 1.5 millimeter hex wrench. So just to keep things from wandering around, we're going to start by just placing our screws in the appropriate location. These are little socket head cap screws. So I cleaned off inside here, but I didn't clean off the screws, which are still kind of gungy. Oh well, it'll act like blue Loctite. We'll just run that right on in. Now I'm not running these all the way in because that would start to clamp the shell together, and we don't want to do that yet. I just want to put these in so that they're pretty close, so I don't have to screw around with it too much when it comes time to mount the heating unit. Alright, and the little grub screw goes on the other part. So we're going to install the grub screw here. Okay, so we want to get the grub screw in there, but not enough that it starts poking through. We'll get to that. So, now the question is, does this come in from the left or the right? This comes in from this side because that's the side that has these on it. So we're going to put that in there, and it just slides smoothly in. If it takes that much effort, I should back these screws out a bit. No, those aren't clamping at all. It's just a rather tight fit. Okay. Now I'm going to do this by forcing on the metal, not pushing on the wire, because you'll just screw up the wire. But you want that to be all the way in. Oh! Yeah, that'll do. I think it was seated deeper before, but I think it'll be okay like this. Maybe I can do a little better. Maybe. Well, it's flush, and it's flush on both sides, so I'm calling that good. Alright, so that's cool. And I'm still going to clamp that down. I don't really need to. It's certainly not going anywhere. But very bad things happen if that falls out. So it's important to have it nice and secure. And you don't have to reef down on this. If you want a really fascinating field of study, get into researching the holding power on fasteners versus the amount of energy put into tightening it, and it'll blow your mind. The compression force, the clamping force that you can generate with just a 1/4 bolt is astounding. It's really cool. Okay, so this is the part that sucks. And I'm going to put the other thing on first. I'm not going to get into the suck just yet. we're going to put this on here. Now this just slides in and it's going to engage there. So that's all the further down it goes. And I'm going to back this out a little bit just to make sure I can't fall in any further, and I'm good there. And then I'm going to tighten this down. And I'm going to take a minute and go look at the other one and make sure I've got this on in the right orientation. Okay, so this is actually backwards, because when the machine's facing you, like when you're standing in front of the machine, the angly bits go forward and the wire comes out on the right. So I'm going to lay this flat on the table so I know everything's square, and I'm going to push it together this way, and I'm going to tighten this, and I'm going to pat my head while I do it. Oh, hang on, the director and the producer are here. Hi, can I help you? What do you need? What's up? What? Hi, Zoom. So this is Mackie, she's the director. Hi, puppy. And this is Zoom. He's cameraman. Yep. Hi. You're not helping. You think you're helping, but you're not. The whole internet is offended that you've distracted us from making 3D printing videos. Yeah. Woof. What? What do you want? Do you guys need a cookie? Who needs a cookie? Okay. Who needs a cookie? Hang on. It's a SAG thing. They're automatically required to a cookie for day labor here. There you go. Can I go back to work now? Dogs! Okay, we're going back to work now. I'd like to point out that you both had lunch when I went to lunch and are in no danger of starving to death, despite what you would like the internet to believe. Okay, so that's flat. We're down. We're good. Let's make sure it's tight. It's tight. So it doesn't actually mount to that. It goes. Oh, that'll be fun to explore and getting that back on the machine. But I think it goes in like this and stuff's out the top. So the next thing is our thermistor, and then we're done. So the thermistor, now I cannot overemphasize how stupidly delicate a thermistor is. So that goes in the little hole there, and you stick it all the way in, and then you bring the leads up like that, okay? Right up alongside your thing. And then you got to spread the leads ever so delicately, like that, so that you can get the screw in the hole. Because the screw holds the thermistor in. And this is a super simple yet wickedly pain in the butt operation. Let's grab a screwdriver. I don't know if that's a 1 or a 2, so we'll just grab both. And then very delicately, very carefully clamp this down. Don't go nuts with it, because the screw's a conductor, the block's a conductor. If you get stupid and just reef down on this, you'll either break the leads into the thermistor, or you'll displace enough insulation that you'll make a short. So that's done. That's a completely built hot end. And now we just got to bolt it back on the machine, but that's just the 2 bolts through here, and that's easy. And if you've got to this point, you already know where those 2 bolts are, because if you're holding this in your hand, it's off the machine, and you figured out how the 2 bolts work. So yeah, we'll put our little safety condom back on this. Oh, we got to put a nozzle on it. We need a nozzle. All right, so the standard size nozzle is 0.4 millimeters, but you can get them, like there's your generic cheap, but you can get them like 0.2, 0.6, 0.8, all the way up to 1 millimeter. So they come in a variety of fruit flavors. I am using the cheap CC Tree 0.4 millimeter one, only because I don't have any of the sexy micro Swiss ones that are like plated and made out of tool steel and just super sexy. They're much more wear resistant. All right, so I'm going to show you how to install the nozzle on here, and you'll need a 6 millimeter wrench or socket. I'm going to put this in here like that. And best case would be to put this in a vise and really get a good grip on it, but I haven't mounted my vise yet. So I'm just going to hold it down on the tabletop really good. Now I had thought when we began this adventure, last video, that the reason this failed was that I had developed a leak up in here. Okay, up at this seam. Well, that is wrong. I was wrong. I was absolutely wrong. And what had happened was my Z-axis was set too low, and I was ramming this nozzle into the bed. And it wasn't that I developed a leak up here, it's that this was pushed down so hard, it was all backed up and gunging out around everything. So I had a problem due to a incorrectly adjusted setting, and that problem created other problems. Then we're going to put our little silicone condom on here, put it on facing the right direction, it'll work better. So that's our little insulator. And now we're set. Like, I could put some Captain tape on this and tape those 2 together, but I don't really need to. I think it's going to be fine. So we're going to put this back on the printer and give her what for and see what happens. Okay? I mentioned I wanted to get a real look at some of the things that we explored as we've been through this process. So let's start out with the old thermistor, because this will show you how damaged it was. So here we go. There's the old thermistor. There you go. And you can see that's, well, first off, it's in 2 pieces. And it takes a surprisingly small amount of force to split that in half, because it's just a little glass bead. It's also really hard to light. It's just a little glass bead. And if you spread those wires at all, it just splits right in 2. So there is the incinerated thermistor. And most of that goop covering it is just burnt on PLA. So that's a look at our thermistor. Let's take a look at the original heater. There's a lot of gunge. That's just baked on, caked on PLA. Scratch that off a little bit. So let's take a look down at the other end. Oh, It's got writing on it. I didn't know that. What does it say? Let's flip it around. IG 12. I wonder if we can clean that off of it and get a good look at it. Let's see if we can wipe some of that off. That's baked on there pretty good. Oh. Well, I definitely bought the right ones because this says it's made by IG. It's 12 volts, 40 watts, and I'm guessing it was made in March of 2018. So that's cool. And we can clearly see that that was laser etched on there. You can see the patterning. Cool. I'm glad I took the time to have a look. Here's the end. It's just dimpled in, sealed off. And this heating element's still good. Like, I could still use this. So let's look at the other end. I want to get a look at that wire. So you can see it's a copper wire. And there's what appears to be a Teflon insulator, and then the cloth outer wrap, which is probably Kevlar, but I'm not 100% on that. Please comment and tell me if I'm wrong. Haven't really dealt with much of this kind of wire before. I'll bet a good theater geek will know about it, though. You guys deal with lighting wire all the time. So here's the thermistor wire. Now this is the original thermistor wire. And it's much heavier than the replacement stuff, and that's Teflon. Like it's obviously clearly Teflon. 24 American wire gauge. So that's tiny wire. Oh my god, I chipped my nail polish. It's so hard being pretty. Alright, so here we have a brand new nozzle. This is on a different hot end. You can see it's red. And this, from the looks of it, has never been used. Like, it's super clean. You can see the thermistor mounting hole, the screw. Now this one is not a micro Swiss hot end, and you can see it doesn't have the slit for the clamp that the other one did. So I'm going to show you inside a brand new nozzle and a used one so that you can have a really good comparison. Because I have one here that's never been used. This is a brand new nozzle right there, and you can actually see light through it, and that gives you an idea how small it is. That's looking up, the hole in the middle of that is 0.4 millimeters. And there's a nozzle from the other side. Now let's compare that to a giant 1 millimeter nozzle. Now they make them bigger than this. They make 3D printers that'll print boats. Like, that's been done. They have printed a boat. So let's put these side by side. And these are really hard to hold. So there's that giant fire hose on the left is a 1 millimeter nozzle. That's huge. And we can compare that to this well-used nozzle. Here. So now these are both 0.4 millimeter nozzles. That's a new one on the left. and a very thoroughly used one. This is the one that we just removed on the right. And you can see it's technically clogged. There's still goop inside there. So, shiny new, old and busted. And really hard to hold. Let's see if we can... So it's notable, and I ordered one of the really expensive $20 Micro Swiss hot end nozzles, and we'll compare that to this one when it arrives. We'll get a good look at that. But you can see the surface finish on the nozzle is kind of crap. Like, this is the cheapest Gualong Ding Dong 3D printer nozzle there is. But you can see the surface finish at the crown. The crown is the little tip of the output of the nozzle there. It's kind of crap. I am not impressed. Alright, so the next thing for me to do is, I guess, get the actual 3D printer working. I put it back together, so now I just got to get it working just to prove I did it. Let's do that. Alright, time is 15:32. We're back. I just sliced this model. We're going to send it to Ernie. That's Bert. That's Ernie. Ernie's the one we just fixed. So we're going to save the file. ARM top cover. Open the folder. And we're going to bring up, this is Unit 2. So that's Ernie, and I'm using Octoprint, which is awesome. I recommend it highly. This is ARM Top Cover 3 for our robot project. I just shipped it over, it's saving. We give it a second to do its thing. Okay, so there it is, and we can delete that one. We're good there. So we're going to click that. That'll load it up into the dingus. It's going to do some computation for a minute. It's out to print. It sends a call for heat. So we're warming up the bed. Now this bed's different. I never print on glass anymore, but this is just what I had. I gotta find some thicker glass. This is like an 1/8 inch sheet, so it's kind of thin, but I leveled the machine out, so we're good to go there. This is our all rebuilt hot end, and having seen this now and really studied how it goes together, I didn't have any need to leave a little extra, but it's not going to hurt anything. So this is, we're heating up the bed, it's getting ready to go, and we're just going to let that do its thing, and you guys have the luxury of just, you know, there'll just be an edit here. I have to actually wait a minute. So now our bed's heated up. Sent the call for heat to the head. So we're going to watch here and make sure the heat actually goes up. And it's heating quickly, as you can see. So we're going to look over here and make sure there's no smoke or fire or death or pestilence or anything. That long wire out of the way. Yeah, everything looks alright. Okay. Now we're going to go to the control panel and turn our fan on. Fan will come on once it's up to temperature. We're just going to watch right here. So we'll know when it gets up to temperature, the fan will come on and, you know, it'll start moving and we'll get to see it extrude things. So that's what we're looking for right there. is that hot goopy head action. Alright, so if everything works, we'll start seeing goop come out of there. Hey, it's working! No, it isn't. Or a little clogged. At least it looked like it. It looked like it was not feeding right, but this appears to be doing alright. We'll know in a second. I think my Z is a little off. I figured by printing on a mirror it'd let me be able to see it better. But it's really hard to get a shot of that. But we are printing. But I think my Z is still a little too low. Let's see how it comes out. Yeah, you can see some of that's really thin. My Z's still too low. But it's printing, so despite my lack of bed leveling skills, next 3D printer is totally going to have an automatic bed leveling system. One of those proximity sensors and all that. Yeah, because that's my real personal weakness is bed leveling. Like, I know how to do it, I'm not very good at it. But the hot end is working. We fixed it. Maybe you learned something along the way. Maybe you had a laugh or two. I hope so. So that's that. So thank you for hanging out in this particular episode of the Captain's Blog here in the shop, where things are getting a little bit better day by day. And now that I'm done producing this video, I'm going to do a lot of cleaning, because I just got that cabinet in and I got to put all that stuff in it and a lot more. So I'm going to get busy with that. If you like this video, comment, let me know. I'm learning how to edit better. I'm putting a lot of effort into it, and I'm really interested in any kind of feedback. So comment, let me know what you thought. Let me know what you learned. If you learned something in this video, let me know what you learned. Let me know what you thought of like the new camera work, because we're doing stuff with this ridiculous, like this is, I know it's crap. It's a zongy macro lens, but I thought it was really cool to be able to get a look in there and be able to explore deep into stuff. Let me know what you thought of just anything in this video. I want your input. I'm really curious to know what you thought and what your opinions are. And if you're a professional video person and have advice as to how I can do better, I want to hear it, because I don't have all the answers. I'm very much learning how to do this stuff. But yeah, comment. Let me know what you think. You guys have fun. Check the links in the description. There's all kinds of stuff there that you should check out. You could be hanging out in the Discord. You could be hanging out with these weird people. You could be, hey, Jess is there. I just got back on live. I went off for lunch. So yeah, to you, this is all one continuous thing. To them, this has been going on and off all day. So yeah, thank you for hanging out. Thank you for watching the video. I appreciate it. I'll see you guys next time. See ya. Okay, so, oh, I melted the shit out of my mat. All right, we're gonna move to get a different shot at that. Oh, I melted the fuck out of my mat. I gotta put a weight on that. All right, I need a, oh, you'll do. I melted my fucking work mat. And yes, I'm using a 3D printed butt plug base to get that down. Camera sync in 3, 2, 1. Okay, so we're back. Hi, yes, they're still fabulous. Now let's try that again and not melt the workbench top. And you can see the wires stripped. Focus, you fuck. Now let's apply a liberal amount of heat while not torching my hands, melting the table, or setting the camera on fire. And then we'll strip this. That was fucking terrible. And then we'll strip this, which really doesn't work worth a shit with these strippers. All right. Okay, so we just strip the wires. And it totally eats shit every time. Okay.